Okay, the point of today's video is trying to get to understand triangles a little bit better. And I think a main thing that needs to be known when dealing with triangles is the Pythagorean theorem. So as you've probably heard it before, it's the a squared plus b squared equals c squared, where a is one side length. So for this particular triangle, it's going to be 3 squared plus 4 squared is going to equal x squared. And that's going to be the hypotenuse that we're solving for is x. And so 3 squared, obviously 9, 4 squared, 16. And then we need to do the square root of 25. Because x is squared. So since x is squared, we'll have to do the square root to find just x. Because 25 equals x squared. So we have to get the square root of 25 to find x. So that's obviously 5. So that means our hypotenuse is 5. And that's the case for this 3, 4, 5 triangle. That's a general rule, is if you have 2 side lengths that are not the hypotenuse, then your hypotenuse is going to be 5 if you have 3 and 4 as the 2 other side lengths. And when you're dealing with triangles that have a hypotenuse, by definition, they have to be a right triangle or have a 90-degree angle. And the other 2 angles can add up to whatever they may be. But when dealing with a hypotenuse, you have to have the 90-degree angle. And dealing with any type of triangle, they all have to add up to 180. So for this particular one, it has to be 90 plus a plus b equals 180. And more particular, a plus b have to equal 90, since 90 minus 180 is 90. So we know that a plus b have to equal 90 degrees for this triangle, and for all right triangles, since they're all right triangles have to have the 90-degree right angle. And how you go about determining the specific values of the right triangle angles is you use your sine, cosine, and tangent, which are functions that are used to use the relationship between the 2 sides of a triangle, and even the angles, depending on how you use the functions. But for sine, to calculate the angle that it is dealing with, you have to do the inverse sine of opposite and the hypotenuse. For cosine, you have to do adjacent over hypotenuse, and the tangent, it is opposite over adjacent. And you can remember these with your, I'm not sure what the technical term for it is, but SOHCAHTOA. So since SOH makes the SO sound, CAH makes the KA sound, and TOA, TOA, that TOA sound. That's the general tip for remembering these rules. But what these opposite and adjacent means while solving for these angle signs is adjacent of an angle is going to be the one that's touching it. So in this instance, for A, our angle A on the left side of the triangle, it's going to be 4 since it's right next to that 4. So our adjacent's 4, and the opposite is going to be whatever it's pointing to, so the one across from it. So in this instance, that's 3. And our hypotenuse for both angles is going to be 5. But for angle B, the adjacent would be 3, and the opposite would be 4. And so we can now solve for the sine of A using the inverse sine. If you have like a TI-84 calculator, or whatever, you're going to want to hit second and then sine, and that's going to get you that inverse. So we're going to do the inverse sine of opposite over hypotenuse. So our hypotenuse is going to be 5, and our opposite for angle A is 3. So it's 3 over 5. And when we put that in our calculator, we get an angle. Make sure your calculator, if it has like a degree radian mode on it, make sure to set it 2 degrees, or else it's not going to be right, because degrees and radians are different. They're both a measure of angles, but for what we're calculating here, we're going to need the degree function, or not degree function. I think on TI-84s, I think it comes standard that it's going to be degree mode first, but if you need to change that, you're just going to click mode and go all the way down to the degree and radian and just hit enter on degree. But finding the calculation, we get that the angle value for A in degrees is 36.9. And then we can also solve the angle value for B by doing the inverse sine of 4 over 5. And you can also use cosine, but you have to remember to use the correct value. So if we did the cosine for this angle, we could have done the inverse cosine of 3. Since that's the adjacent to B, we could have done 3 over 5, which would have got us the same value as this one, which is 50. Oh, we're going to put that degree sign on that, 36.9. 53.1 equals our angle for B. And we can further test that this is correct by adding these two values together, and we get that they equal 90 degrees, which is what we said it should equal.